So we're gonna brush up ourselves with that mappers and reducers once again, and we're gonna see that input splits one more time, and then we're gonna go through a couple of classes. There are a long list of classes. At the moment, it's really difficult to go through all of them because we could be stuck here for, few more days. So the goal is to try to get into this MapReduce program by the end of this session. And we're also going to see that writable interface. We're not going to see the exact implementation, but we're going to see why they're using it. So far we have seen this two HDFS and part of MapReduce, which are two core components of this Hadoop framework. So the MapReduce is responsible for a few things that we also see in the job tracker, task tracker, and how they work and who is responsible for what. And also this MapReduce is not a programming language. We're still going to use Java, but it's a new approach of writing a program. It's a new programming model, and this makes it possible because on Hadoop there are multiple processes running parallelly, so it makes it possible that communication among all these processes or objects and data transfer among the objects, and the core concept is that parallel processing across the distributed network. So this MapReduce class library, it makes it possible. So we also have seen this, how a file will be split at the beginning, and then there's a record reader is going to actually get extract text out of it, and then that's going to go to, yes, that's going to go to mappers. Mapper is the actual logic we're going to write. And then there going to be a couple more phases uh, that sort and shuffle, and then the reducer, and then the reducer is going to actually write the output into files to the HDFS. Okay, so we have seen with an example of that counting population across state of California. If we treat that whole California as a big data set, and then the way we would be doing it is split that into a different cities, towns, and then assign each city to a person, and then they're gonna do the counting, and you give the person very specific instructions about what to do. They're gonna do the counting and bring back the results to the head office, where the person sitting at the head office would be doing the aggregate. So the whole California state is the data set, the cities and towns are the input splits, and the person who is doing actual counting is the mapper, and then person sitting at the office is the reducer. The sorting and shuffling is done by the framework, so we are not actually implementing or doing anything about it. And then the reducer is going to write that output, the expected output. So there are few more things of why we needed this input split. So we were having the blocks, so everything was good because in HDFS the way it is going to store data is in the form of blocks, and we were also talking about block sizes and everything, and suddenly that when we came to MapReduce, the new word is input splits. So the basically file is divided into input splits. Each input split is fed to a mapper, and the number of mappers we need depended on the number of input splits. If there are 3 input splits, and we would be running 3 mappers, but we're not going to decide it, and the framework is going to decide it. But if there are 100 input splits, 100 mappers would be running. So let's dig a little deep into what is this input split. So this we were having blocks. Then what was the need of this input split? Why can't we just divide it by the blocks and assign a mapper to each block and work it out? Because we were having block size of 64 or 128 MBs. So the problem with the blocks is at a uh, MapReduce logic layer level. So when the file is stored, if you are, looking at this file which is split into 100 MB chunks. So this is done by a class in the framework. So it is not going, it's not, it might not be exactly 100 MB, it could be anything, but it is going to decide depending on the logic they wrote in that input format class. We are also going to see that little bit about that class. So there are, if you have 4 records of each of 100 MB. So if you are trying to store this in blocks of 128 MB size, so what's going to happen? The first record is going to fit into first block perfectly. So up to that is okay. But when it comes to the second record, 28 MB is free space left in block 1. So 28 MB is stored here. Another 72 MB would go to block 2. And then comes down to the third one is gonna, part of it is stored in block 2, part of it is gonna go to block 3. And it's gonna go on because they are divided into blocks. So not everything would be on the same block. But when it comes to this MapReduce logical layer, so to solve this problem, this spread across different blocks, when each mapper is trying to read one record, it is spread across 2 or 3 blocks. Instead of that, it wants to read it at once. So we would be using this input split. Basically, the framework would be implementing it. We are just trying to understand it. So this is going to solve that one problem. This blocks, the file is spread, sorry, not the file, it's the record is spread across multiple blocks. So with the input split, what it is going to do is, it is going to put first one and the second record, and it is going to put a border there. So it is going to create logical boundaries so that the record will not be split. It might be spread across blocks, but the records will not be split. So the first input split is fed to first mapper. So first record, second record, both of them, it is going to process at once. But this is done at that framework level. So we will not be doing anything about it in our code. But to have an idea, I got this picture, and let's also see the input format class. So the input format class is responsible for validating the input data. So when we are trying to run the MapReduce program, so it is the input format class which is going to check whether the input path file is existing or not. That's the first thing. And then this is responsible for turning that file into input splits. And there is an implementation of record reader which is going to extract the records, and in our case it's the text out of that file. And then we're going to perform operations on that. Records are, in our case, whatever we are going to do is text. And output format class. So the input format class works at the beginning of the MapReduce program. The output format class works at the end of this MapReduce program. So at the end, it validates output specifications, mainly if there is an existing folder with the same name, the HDFS won't allow to overwrite it. So the override operation is, not possible. So we have to make sure if the same name doesn't exist, XDFS, and then it is going to write it. So it makes sure that the whatever path we have mentioned, uh, it makes sure that it doesn't already existing on HDFS. Also, like
Srinivas,
yes.
uh, so do we write these files externally, or will this get generated
Uh,
and we
it
will?
get generated, but we're gonna define path in the program. So where it should be writing the file. So we're gonna give that path as an argument. Does it make sense?
Okay.
Because it is not,
Okay.
all these things are going to make sense once we start writing the program by end of this session. Okay.
Okay.
Or probably tomorrow we're going to go through few more classes and one more program. Because that we're going to write three classes: mapper, reducer, and a driver. Mapper reducers are mostly something similar what we did yesterday, but in driver we're going to come across few more classes which are new to us, but really don't worry about it today. So let's finish this off, and when we come back tomorrow, we're going to go through some more classes, or probably everything might make sense today itself. But let's say this output format class is similar to input format, but input format class is going to do its work at the beginning of running that MapReduce program. Output format class is at the end. So it is going to validate if there is an existing folder with the same name, with the same path, and then a record reader implementation would actually write. So when we are saying record reader implementation, we are not going to write it. It is already the part of framework. So we're not going to write this part. We are only trying to understand it. And there is also just one more problem they were facing initially when they were using that Java primitive data types. So they came up with a few new data types, especially for Hadoop. So everything else is Java, but they're using just a few primitive, data types. But they wrote that in a class, a new class. They kind of wrote a wrapper around this int or string, and they created new classes, which they are calling writables. But for all these things, they started with a interface, a writable interface. The problem was these are the incredible long writable. These are the ones that we're going to use in MapReduce. But what was the reason why these guys had to go for these new data types? So the one problem was the serialization and deserialization. So if you already have an idea about this serialization and deserialization, it is if you are trying to send an object over the network, we do serialize it and turn that into a stream of bytes. And when it reaches the other end, we're gonna construct this same object uh, from this stream of bytes. So whenever we are transferring data over the network, so there is a need of serialization. As this is a distributed environment and the data is very frequently transferred over at a faster rate over the network all the time while running the jobs. So the primitive data types of Java out of the box, they were not efficient. So the out of the box primitive data types of Java were not really efficient. So they wanted something fast, compact, and effective. So they came up with these new data types for Hadoop. Apart from that, everything is same. So these are the new data types. Uh, int writable, we're going to use it in place of int. So most of them, you can actually assume long writable is in place of long, float is Yes, float writable for floats, but in place of string, we would be using text. So if you want to, go and see the implementation of these, they should be available on in documentation and Apache website, Hadoop website, and the two methods they wrote in that interface, or that write and read phase, I believe there should be one more. But we don't have to really dig that deep. But if you are curious, you can go to Apache Hadoop.org website. There, you can have a look how they implemented it. So this is how we're gonna run the program. Let me see. That is. So that's a syntax to run the program. After writing the Java program, we're gonna create a jar file, export a jar file, and it should be something like this. Hadoop jar. If you are saying word count dot jar, so this is under HDFS, a new command to run it. So keep it little separate. And we're going to write three classes: mapper, reducer, and a driver class. So whatever we wrote in the last session, we're going to divide that into three parts. So driver class name without extension. Say normally we could be using driver, yes. And input path. So whatever we were using, home, training, Hadoop, and test one, and output path. It was user, again training, so HDFS 1 or something. Then no, if we give that, it is going to throw an exception because this is an existing one. Out, and that's it. This is a new command in HDFS to run the actual MapReduce program. So with that, let's go ahead and try this program. So Srinivas, if that makes sense, earlier you were asking about this, isn't it? So we're going to pass this as an argument while running that program. So it is going to create files right there. So we're not going to write any lines of code actually to create files. So most of the common things are done by the framework. So we'll see in a bit that. So we'll be doing the minimum things.
No, we just mentioned the path, right? So where do we configure the format of the output?
So that will be in the driver
Okay.
class. So we're gonna mention that in the class. Without mentioning it as as an argument, so we can't be giving that here. So we're gonna mention that in driver class. Driver class is where that main method is. So let's go ahead. It's going to make more sense if you see. In the program. Let's go ahead. So this was it? Yes. This was the program we wrote last time. So we were using that to analyze and string tokenizer to divide the data into words and with the delimiter space, and then we were running a while loop to get each word out, and then adding that to the array list, and then we were checking if it is already existing or not, and if it is existing we are increasing that count and we print it out. Let's see how we'll implement this into three parts. So new Java project, So word count 1. So in case if you create one more, let's go and create a package because we're gonna create the 3 classes. I would say word count, and as I mentioned, here we need 3 classes. Let me take it. So one is mapper and reducer. So these are the faces we have seen in those pictures and slides, and the driver class from where we actually run this program. So let's create a class, then mapper. So because there is a mapper class already implemented in the class library, I would add one. Same with that reducer. And last one, the driver with the main method.
Then Srinivas,
Yes.
shuffle doesn't need any.
No, we don't. I mean,
Okay.
it is a responsibility of the framework. We wouldn't be doing anything about the shuffle and sorted. So we
Okay.
only would be writing the logic for that mapper part and the reducer. So in between, it is the that frameworks part, our responsibility. Okay. Right. So let's start with this implementing the mapper. So this is gonna extend extends the mapper. So here that is kind of, it is extending the one they defined, but here say initially, so what kind of input it would be getting and what kind of output it would be giving. Say we are talking about mapper phase. So it is going to get words like Hadoop is okay. So it is going to get the words as key value pairs as inputs, and it is going to throw output as something like this. So that's what they got here. So it can be like text. Now the text should make sense, but we say key value pairs. It could be giving it an ID, but we're going to change that in a bit. Right, table, comma text. Say this is the input key value pair. But before we go any further, we need some external, we need to import a few class libraries, Hadoop class libraries, which are not part of the Java, so we may have to import it using external jars. So this is build path, configure build path, and it should be in libraries. So I already got these few class libraries downloaded, but for the moment there are a long list. There's a long list, but for the moment we only need these three: and core and examples. And if, if we are going to write, I mean, further down the line, we probably, yes, would be importing some other jar files. Saying okay, and I need to now import apache.hadoop.mapreduce. The same way, even I need to import this iterable. It is in hadoop.io and the text hadoop.io. Because I mean we haven't written that output key value pair. So output key value pair would be text, comma, iterable. So we are talking about something similar. So here we are not going to give, say this is input and this is output. But input, we are only getting that words, but we are not going to define any count of anything. It's going to be some ID generated by framework. Say if it is giving some ID, and then it's going to be some other ID. So they are calling it an offset value, and this is generated by framework. And later we don't need this at all, but the class which is extracting them, they need it. So, but I mean, we could be using this, but the offset value is, we don't know exactly which one is it, so we can write object, kind of universal. Yeah, even we could use text because that's kind of a code it is giving. So text also works. Yes, we are set to go. So what we need first. So if you go back and see, if you could remember that the program we did earlier in the last session is, I mean, very similar, but only a few things gonna change. Let's see it. So initially what we're gonna do is we're gonna assign one to each of the word. Where was that picture? Yes, something like this. Whatever comes in, we're gonna assign one. David 1, Ian 1, again David 1. So last time we weren't doing this, we were because we were checking even before assigning one if it exists, already exists. If it already existing, so we are not adding it as a separate element, but we are going back to the same element and increasing the counter, increasing the count. But here, these are all separate parallel, I mean, process. So initially we are not doing that here. So we're gonna assign one to each word, regardless of whatever it is. So we're gonna create a constant. So it's not even counted, just one number we are creating, because we're going to give one to everything. So I'm initializing it to 1. Can you put some comments there? Initial, we don't, it's okay. Right. So we got that 1 into an iterable with value initialized to 1. And what else we need? We need a word to hold the word, and now we get the word. So here it's not string. If you remember from the slide, it's text. Sorry, new text. Then there is one method we're going to override, and that's where we're going to actually write the actual logic. It is the map method. So there are 3 arguments we're going to use. So there's a key value pairs for inputs and outputs. Here object is going to be key, and so text value is going to be the text is going to be a value, and for output we need 2, but in place of those 2 we're going to need text and iterable, word and its count. But in place of that we're going to use one text class object. This is kind of holder which we use to transfer the data from, say, mapper to the reducer. So it's a kind of a common place from where this is going to write and the reducer is going to pick things from. So what we need? So we're going to need the same string tokenizer to divide them, but here the data where we are getting data from, it is from a file on HDFS. But once we get that, we're going to have that in the value. So this is the input part, and that's output part. We're going to have that into the value, and then we're going to give that to the same as previous session, to the string tokenizer, to divide them into words using delimiter. The default one is space. So we need to import that string tokenizer. Let's fix this. Import. Right. We're going to get the input from value, but the value is of text type. This only takes a string, so we can use the string method. So we just got that input to the string tokenizer. So into the string tokenizer object, str. So it's from here. It's similar to It's very similar to what we did yesterday. Because in this method we're going to implement the same thing, but not all of it. Here we're going to get these tokens out of the string tokenizer object, str. We were using while loop. And then the method was has more tokens. it has more tokens, what we're gonna do? We're gonna add that to, insert that into Word. What is the text dot so it is the next token. It would be having in the next token method. So now we have the word into the first word into our word. So what's next? It's almost done. We would be writing this. So context is actual class. So context object. In that there is a method called write. So inside it, say it takes two parameters, text key and iterable value. So here the output is going to be the key is going to be the word and the value is going to be the count. This time it's only one. For every word it's only one. So key is going to be key, isn't it? From there it's key. No, the key is going to be the word. Let's go back here. So in the first mapper phase the output would be series 1 1 and then again one more Hadoop 1 more is 1 say 1. It is going to be like so the key is the word and the value is iterable just 1. It is not going to change. That's why we got a constant. So this is word and this is where the value is always going to be this 1. See, side throws declaration exception. Yes, that's the end of the mapper. So here we are not doing much. We are only doing up to this. And in the reducer, we're gonna catch all these things and add them and write them to the output. Let's go and reduce. Yes.
Srinivas,
Yes.
for the mapper1 class definition, right? Extends mapper.
Yes.
Object, text, print, writable.
Yes.
The last two I know that these are the last two is the output basically, text and print, writable.
Yeah, the last two are outputs and the first two are inputs.
Okay.
Yes.
So where is this thing being given? It is it the from the command line whatever path that we?
Yes, the command line we're going to give the path of the actual file, but from the actual file to coming up to this, it's going to be part of that framework's work. So we're going to give the path, just like that we were mentioning there. So we're going to give that path of the file. So this file will be divided into input splits, so which we are not going to do. And then the records out of it were are read by record reader, and then they are given as input to the mapper. So this is this whole part is done by the framework. So then we are picking it up here and writing our own business logic inside this map, overriding it.
So this is actually giving you this object will be giving you the input. File.
Yes.
This, and the text part, what will that be giving?
You mean this input part? This to object comma text.
The object will be giving you the input files.
Yes.
The input files to mapper. And
Yes.
the second part, that is the text, what will that be giving?
Text is a kind of a record. I mean, what they are calling in that framework, it is going to get the record out of it. But the record is, I mean, the way they implemented is, if it is pure text, end of the line, it is, I mean, taking as a record. So it's like a whole sentence. So that is going to go into one input slot. Hello.
So you mean to say that the second value text, that is one record?
Yes. And that record it will be, I mean, we are dividing that into words.
So how does that value get mapped to value.toString, right? How does that get mapped to the text?
This is, say, if there is a one line and in value, if that is, we are changing that into string and we are dividing that into.
No, I got the string tokenizer part.
Okay.
My question is,
Yes.
how does this map thing, what exactly calls internally, will a Hadoop call the map?
Yes.
Okay.
So it not only calls the map once, but multiple times for every record once. It's like it's gonna, I mean, if there are, say, input splits are 100, 100 instances of this class will be run at the same time. So that's the difference between that, I mean, the previous program and this one. Shall we implement the reducer part?
Yeah.
Okay.
Srinivas, before
Yes.
that, just can you reiterate the mapper class purpose?
Yes. So
The input object and text int, right? So the 4 parameters.
these 4 parameters. Okay. So the object part is, I mean, is done by the framework. Initially, it is going to get records and it is going to give some offset value, and it would be something like that. And we're not going to need, I mean, we're not going to use this at all. We don't need this. But it is, the framework is going to use it. It is going to be, and the first record, if it is Hadoop, is something like this. And this is going to be input one record, a line, and then we're going to ignore this, and we're going to take this part, the value part, and we're going to divide that into, I mean, we're going to, I mean, give that as input to string tokenizer. That makes sense. So we're not using this one, but we are only using this.
Okay.
Okay. So but this context part is, I mean, it is having to pass this data onto reducer. That makes sense.
Yeah.
All right.
But I internally didn't get the whole context of this mapper.
Okay. So probably we may have to, I mean, dig deep, but I mean, in coming 1 or 2 more sessions, probably we try doing it, because this is the first time I mean, dividing this into 3 parts and using the actual classes from the, I mean, extending the classes from the class library and overriding the methods. So might look little, yes.
And the use case is that you got, if whatever the file you got, one file, you are trying to place it in Hadoop HDFS system, or you want, and you're trying to process it, right?
That's correct. That's correct. So I mean,
processing that.
Yes.
Yeah. Maybe can we just highly in 2 sentences reiterate the use case we are trying to implement?
Yes. What we are trying to do is we're gonna, I mean, place a text file on HDFS, and we're gonna give that as an input, and this our program with the mapper, reducer, and driver, they're going to pick it up and process it and write into another file on HDFS, the same output what we have seen in WordCom program in last session.
Okay.
So that makes sense. Probably I should have mentioned that probably even before we started it, but yes, we are trying to do the same thing as we did in the last class, but in a MapReduce way. So it is going to take it. We're going to give it place a text file on HDFS, and we're going to write some logic in mapper and driver, which is going to pick up the file and read it and get that words out of the file separated, and count the words and the same as last time, how many times it's repeated, and it is going to write that output into a new file. Does that make sense now?
Yes, Srinivas.
Okay, so probably once we write and finish this off, and probably we're going to come back. That's why last time I was saying probably this might take up to an hour at least, writing it for the first time. Let's go ahead and implement the reducer part. Yes, so here also we're gonna, this should be extending the reducer. And here, just like the previous one, what will be the input key value pairs and what would be the output key value pairs. So it only takes that key value pairs and gives out key value pairs. So it is going to be output of the mapper would be the input to the reducer. So output of the mapper, we're taking this would be the output of the mapper, but now this is actually the output of a whole program. So if it is a mapper, this would be the output. So if I missed that, it was little misleading about this one. So if that earlier question was about it, here it is. So output of the mapper should be this. So the number is the output of the whole program, the reducer. So output of the mapper should be this. Is now making more sense? Okay. So output of the mapper would be the input of the reducer. So this one is key and this one is the value. So text interpretable. And what would be the output? Output would be, say, here I would say, reducer's input should be that and the output should be so then again it's going to be text and interpretable. So input is text and interpretable and output text and interpretable. But okay, let me import these things. And text. Yes, but in between, so we are saying that output of this mapper would be the input of reducer, but in between there is a sort and shuffle. So here, this would be changed if there is one more Hadoop. And this should be changed to it should be that way. Let's go back and see. So EON 1111, and it is going to be actually EON 4 ones. So this is gonna reflect at the method overriding level. Let's see. So I think that was a little misleading even for me whenever we were talking about the input to that mappers. So it's all in there actually. I should have been referring to that in the picture, and probably try to get a better picture exactly how it is working in the next class, and we're gonna see just one more of this. Probably we could get it little bit. So for now, let's finish this one, reducer. So it's going to be input that, and output is going to be so it could be 3 and it could be 2, and output should be something like that. Let's see. So we need one more iterable for the result. Call this as result. Okay. Then we're gonna override the reduce method. And all the logic actually gonna go into this. And here is the trick. If we get this, it's almost done. So the input would be, the key would be the text, the word, and the output would be, if it is that form, use one more data structure, and it's going to be of iterable. And output would be again the context, but it is going to take that key value pairs context. Because we haven't given name to this, we call them values. So I'm going to write a for loop to iterate through all the numbers, mostly ones, through the values. So I need iterable. Value, and then I'm gonna add each one. It is something similar to this. Add each one and store that in a result. So I need one more integer. So I can't declare it here. It is going to declare it every time. Int sum. Initialize it. Let's go back there. I'm gonna get it. To get it, I'll add get this is going to get the value out of it, and it store this in sum and add that. So we have the total value into the sum. All we have to do is put that into result to display it. The reason why we can't just give this to context, so context right, we're going to do the same thing as context right. As a key value base. So here text is, so we are going to get the text right from there, so it's a key itself. So value is, why can't we give sum here? Because it's asking to change the type sum to iterable, because this is going to go into right into Hadoop environment again, so it only understands iterable, not the int. So iterable we got is result. Let's see. Throws. Yes. So does this one make sense? Yes, guys. So because, I mean, this is it. We wrote all of the logic what we were implementing last time.
Hey,
Okay.
Srinivas,
Yes.
just a question.
Yeah, sure.
How does the sum get populated into the result?
Oh yes, actually I did miss it. That's a good question. I was talking about that we can't use sum, but that's why we got result, but I didn't get that into the result. Yes, that's a good question. It's like the get method, it is set method. Yeah, thanks for that. Are you gonna give some input? Okay. Yes, and then
Is it not possible to do an addition on the int writable itself instead of having it?
yeah, it is possible, but I mean, normally what we are trying to do is whenever we are trying to write it back, and then I mean, whenever there is, I mean, not possible, then only we are using that int writables. So rest of the logic we are trying to implement in our old base.
Okay.
So the last part is the driver. So from here we're gonna run the program. We are not writing, I mean, any logic, but we are gonna write some configurations. And I mean, now when we write that program, you all guys have all these questions. Even Ramya was asking earlier, I mean, how this is gonna know, I mean, where it is, from where we are trying to, I mean, uh, run this program, and where the input is, where the output is. So for all those things, we're going to define them in here. And there is a list of these definitions. So for that, we need one object, job object. So we're going to have everything in there. Let me import this. Yes. So this, okay, close declaration. This takes few parameters. It's going to take one configuration object and a program name. That's we can give anything we want. Let's define a configuration object. So this part is going to be, I mean, almost same for almost every other program. So our main logic would be in the mapper and driver. It's not showing up. Yes, from here, I mean, we're gonna define a long list of configurations. So the first one is job dot set job by class. There it is. So here we're going to give the driver class name. Java class. So we have to always mention this dot class. And what else? We have to hello.
Sorry, traffic enough?
Hello. Hello.
Yes, I can hear you.
All right. Oh, sorry. There was a power cut. I just managed to connect it to my hotspot, mobile hotspot. Okay. So we are trying to define. So yeah, all these configurations. The other one is we're gonna let this know what is our mapper class, what is our reducer class. So the same thing, the same way, job dot. I think I'm audible, isn't it? Set mapper class and the same way reducer class. There is also one more class called combiner. We're going to see that probably in the coming classes, coming sessions. So our mapper class was mapper1. So mapper1 dot job dot set reducer and that is reduced one. And we also have to, define the output key value data types. It's the same using job. Set output key, output key class. Excuse me. Output key class, and that would be text, and the same way output value class. This would be, where is that? Need to add it. Set output value class. This one would be interactable. And then we need to, while picking up the file, we need to, how it is going to pick up the file and where it is going to write it. So here there are two lines. Input format class. Format dot add input path.
Do we need to
Yes.
mention this in two places, both in mapper as well as in driver?
No, it's only here, because in mapper we are not saying anything.
In mapper also we mentioned that, right? Text interactive, the object.
Oh yes, that is the kind of, we are extending, what is it?
The map.
Yes, this one, this method and whatever we are extending, we are not actually writing this one. This is from the class library. That makes sense. We are only extending this class because this is already implemented. It is in the class library.
Yeah, but my question is like, so the what the object types we are giving here, the input value, so that should be in sync with the driver class, what we are defining now?
Yes, you mean here, whatever we are deciding.
So suppose here I define something long, and if I define something int in, obviously that gets failed in compile level.
Yes. So what you just asked means this one, and you mean this one, this part here. Okay. So this, I'll have to check that out actually, because I was only thinking of that the earlier I was talking about file input format class, and we are only setting that when it picks it up, and we are only configuring the job class, that is the mapper class. So there are two different classes. I will have to actually check it out, even test it. But for the moment, let's finish this off because. Okay. So that's an excellent question, because me myself haven't tried it out. But these are two different classes where we are setting these values to. We'll have to see whether they are going to just cross-check with each other. So the path. So technically we need to, this takes path, but we are not actually giving the path because we're going to give it at the runtime. So I'm going to use that path object and at this. ARGS of 0, first argument. This set output path. think picking up.
This will be at the task level or at the job level of the map reducer. Whatever we are mentioning here, the driver map
It's a
reducer.
job level. It's a job level. Yes. Because the task level, I mean, we will not be, I mean, doing anything. It's a job level. So for each job, it is going to run.
Okay. So can we reuse one mapper or reducer in some other place, or it should not be?
You mean the mapper object we should be using?
Yeah.
Technically, it would be using it, say, maybe 100 times. 100 instances of mapper would be running if there are 100 input splits. So what you just mentioned is actually the framework would be running them parallelly 100 instances. Yes.
Okay.
And here, gonna define path again, and so one. Yes. And yes, that's it. There is one system exit process which is common to everything. But what it is, take our documents. So it is we're gonna use this method, wait for job completion. That is, it's a Boolean type. It's gonna be in Boolean. It's gonna take a Boolean, sorry, and it is true or false. So this line is kind of a common before, I mean, exit process in almost every. So this driver part looks, I mean, more or less similar to almost every other applications. We're going to define these common things, but the actual logic goes into the mapper and the reducer part. So let's quickly run this and see, because we are going, we might be going, we are already going over the time. And then when we come back tomorrow, we're going to dig a little deeper and see if possible with one more example. Is that okay? So we need the jar file exporting. So select jar, next WC word count. Let's finish it. Let's go and check it. It wasn't there. Yes. So we need the jar file, copying it and taking, I mean, to that my VMware. I should have started the VMware earlier. So are you guys okay if this might take another 5 to 10 minutes total to finish, maybe 10 minutes? If someone is running late, we can, I mean, come back tomorrow and see this part. Hello?
I'm okay, Srinivas.
All right.
Yeah.
So all we have to do is, I mean, now, I mean, this should make a little more sense. So we're going to copy this at one place, the jar file we have created, and this is the command hadoop jar, and give this file path, and then the actual driver class name where the main method is, and then the input file path, and we have to mention output path. So if possible, I will try to uh, put this into probably bullet points, whatever we are trying to do. I mean, along with the program, and mail that to you guys, because without having what's happening and what we are doing, even if it was a little misleading at the beginning, probably we take an image which clearly explains this. If we could follow that image and these bullet points, we should be able to, I mean, do the program. If that is not right, I mean, this could be very misleading and very confusing. And probably that could be even useful to me, because I got few pictures, but still kind of mixed up at one point. So I'll try to put, I mean, these things with an image and a few bullet points, and mail this program to you guys probably tomorrow. So I mean, that's something similar to this. Instead of putting that into a notepad, I mean, try to get an image which explains this perfectly, and then some bullet points to follow. I could have opened this little earlier, but if I wanted to, I mean, keep it open from the beginning, it is kind of slowing the system down. Okay. It's not in there. We are working from there. Smart. Yes, that was the folder we were working. So just pasted it. It's not doing anything. Let's see. Maybe it's hanged. Copy. No, paste is not coming. Yes, wasn't loaded. And you can go back there. So it was Hadoop jar. Oh, come on. Yes. So jar file name was, we have to give the total path. Instead, what we could do is Peddi Hadoop 1. There it is. Hadoop jar what comes one dot jar, and the driver class name. Driver class name, we use a driver without that extension, class extension, and then input path. Probably I'll maximize it. Input path of the file. This should be an HDFS. So the jar file can be on the local file system, but the dataset should be on HDFS. User, I believe we have test 1, 2, 3 even on HDFS folder. Meaning we got HDFS 1, and I'd use the test 3, which is a image of two things from last session. Thus, input path and output path should be, there shouldn't be, the directory shouldn't be existing. Let's hang a bit again. Yes. The same training, and that was bad. Hello? Hello? I think something gone really wrong, because that it took 5 minutes to load, nearly 10 minutes to get to that point, and got closed suddenly. Shall we, run it when we come back in the morning? We can actually brush up a bit of the program and run it, because sitting here for 10 minutes waiting to get this open is no point. Is that okay? Okay then.
First we will look into the
program once again, and then we run and see it. Okay. All right. Okay then.
Okay, thanks.
Thanks a lot, guys. I'll catch you up tomorrow around the same time. Okay. All right. Bye.